Good morning, one and all. This is U. Chandra Rao, sir, Triple Department. Now we are going to discuss about passive elements in electrical circuits. Before going to discuss about the passive elements in electrical circuits, first of all, I would like to explain about the electric circuit, then Ohm's law, then we will go for passive elements. Electric circuit. First one is electric circuit. What is mean by an electric circuit? Actually, circuit is nothing but interconnection of various elements. Interconnection of various elements is called circuit. Electric circuit means interconnection of electrical elements. The electrical elements are either maybe a passive elements or active elements. Passive elements as well as active elements. Here, the electric circuit has supply and load. Supply and load. This is the load. Load or element. Electric circuit has supply and load or element. Here, electric circuit can also be defined as a closed path followed by electrical current. A closed path followed by electric current. A closed path followed by electric current can also be called as electric circuit. A closed path followed by the electric current is also called as electric circuit. Here, the supply is active element. Active element means which supplies the energy to the circuit elements. The element which supplies the energy to the circuit elements, that is called active element. Now coming to this load or element. Here the load or element means, here at this concept the elements are passive elements. Either passive elements means resistor, inductor and capacitor. Resistor, inductor and capacitor. These are the passive elements. Here at this stage, at the load or elements means, here the load is either maybe a resistive load or otherwise inductive load or otherwise capacitive load. The load is either maybe a resistive load or inductive load or capacitive load or a combination of these three, that is either RL load or RC load or RLC load. RL load, RC load or RLC load. The loads are any of these. Okay. Now here electric circuit means a closed path followed by electric current is nothing but electric circuit. For example, here let us assume that the element is a resistive element R. Now the next one is Ohm's law. Ohm's law states that the current passing through the element, which is directly proportional to the applied voltage. The current passing through the element is directly proportional to the applied voltage. What is applied voltage here in our circuit? The applied voltage is a supply voltage. Now here the current passing through the element is current I. The current passing through the element is current I. The current passing through the element is I. What is the element here? Resistive element R. Resistive element R. Now the current is I. The applied voltage is V. Now in this circuit, the supply is V volts, load is resistive load. Now it is a closed circuit, closed path followed by electric current. It is an electric circuit. Now according to Ohm's law states that the current passing through the element which is directly proportional to the supply voltage or applied voltage. Okay. Now if the proportionality is eliminated, then current I is equals to V by R. I is equals to V by R. Then what about this R here? Here R is resistance. R is nothing but resistance of the resistor. R is nothing but resistance of the resistor. Now actually here R is constant. Then if R is constant, then I is proportional to V. R is constant, then I is proportional to V. If proportionality is eliminated, then I is equals to V by R. Why here R is constant? This is a question mark. Why here R is constant? Here the resistance of the resistor is directly proportional to length of the resistive element and inversely proportional to cross-sectional area of the resistive element. Here resistance of the resistor is directly proportional to length of the element and inversely proportional to cross-sectional area of the element. Here, what is the length of the element? What is cross-sectional area of the element? For example, if we consider a conductor, one conductor of this much of thickness, then this conductor has this much of length, and the cross-sectional area of the conductor is, this is the cross-sectional area. And moreover, this conductor or the material, the conductor which is made up of certain material, either copper or aluminum or some other any other type of material. Now for a copper, it is the material is constant, or otherwise aluminum, the material is also constant. Now if the proportionality is eliminated, then R is equals to rho into L by A. Here I was already told you that L is the length of the conductor or a material or a wire, and A is the cross-sectional area of the conductor or a material or a wire. Now coming to what is rho here, the rho is called specific resistivity. Specific resistivity. What is specific resistivity? It is the specific resistivity rho is constant. So the value is either maybe 100 or 800 or 1000 or like that. Why it is 800, 100, 1000 or like that means that? It means that this is a one particular type of conductor. The conductor is either a copper conductor or aluminum conductor. Now for the entire wire or for the entire conductor, it is either a copper material or otherwise a aluminum material. Now the wire is a constant material, made up of with a constant material. So that's why here their values are also constant. Okay, this will tell us that property of that particular material, either copper or aluminum. Here rho is constant. For a particular resistor, material is constant, that's why rho is constant. That's why here R is proportional to L by A. Then for example, if length of the conductor increases, if the conductor length increases, resistance also increases. That means R is proportional to length. For example, here, if the cross-sectional area also increases, if the cross-sectional area also increases, if the cross-sectional area also increases, if the cross-sectional area is also increases, if the cross-sectional area increases, the corresponding, if the cross-sectional area increases, the cross-sectional area increases, if the area increases, the corresponding resistance is decreases. The corresponding resistance will decreases. So then, if the length increases, resistance increases. If the cross-sectional area increases, resistance decreases. For example, after made up of one resistor or a resistive material or a rheostat, resistors are two types, fixed resistors are precision type and ohmic type. So here, the rheostat, in case of rheostat, it is made up of with some certain type of material wounded in a wire wound type of rheostat. So that's why here, that is after constructing or after made up of the resistor or a rheostat, the particular material is constant, rho is constant, and the length of that material is also constant, L is constant, and cross-sectional area of that particular material is also constant, A is constant. So if all these elements are constant, then resistance is constant. If the resistance is constant, then I proportionals to V. If resistance is constant, then I proportionals to V. Okay. Otherwise, I is equals to, if proportionality is eliminated, finally, I is equals to V by R. This is the Ohm's law. Okay. At a constant temperature, here, the Ohm's law states that the current passing through the element or a circuit which is directly proportional to the applied voltage or a supply voltage at a constant temperature. The condition is at a constant temperature. Okay. So here the temperature is constant, length is constant, area is constant, particular type of material is also constant. That's why R is constant. If R is constant, then I proportionals to V. This is about Ohm's law. Now, the type of elements here, what are the types of elements? Here, the type of elements are either resistive element, inductive element, or capacitive element. Resistive element, inductive element, or capacitive element. What are the types of these elements? What are the property of these elements? Now we are going to discuss about the resistor. We are going to discuss about the resistor. Resistor is, resistance of the resistor is represented with R. Okay, it is already explained with the help of this diagram. Resistor is made up of either a copper or aluminum with some certain length of wire. Okay, it has certain cross-sectional area, and the material is either a copper or aluminum. It is already explained. Now, what is here? The question is, what is a resistor? What is a resistance? What is a resistor? What is a resistance? Resistor is a device. Resistor is a device or a component. Resistor is a device or component. Resistor is a device or component. Now, what is coming to resistance? What is resistance? Resistance is the property of a material. Resistance is the property of a material or a device. Property of a material or a device which opposes the property of a material or a device which opposes the flow of current, which opposes the flow of current in a circuit, which opposes the flow of current in a circuit, closed circuit, flow of current in a closed circuit. This is called resistance. So here the difference between resistor and resistance is, resistor is a device or a component. Resistance is the property of that device or that component. What is that property? That property is which opposes the flow of current in a closed circuit. That is the property of the resistor. Okay, the property is called resistance. Resistor is device. Okay, now coming to the inductor. What is inductor? Inductor is also a device or a Inductor is also a device or a component. Inductor is also a device or component. But this device or component also has certain property. The property of inductor is called inductance. The property of inductor is called inductance, which is represented with capital L. The property of inductor is called inductance, that is represented with L. What is that property? Actually, inductor, how it is constructed or how it is made up of? It is also made up of with either copper material or some other material. Okay. Now, inductor means we have to take certain length of wire. We have to take certain length of wire. Now, this wire is twisted. Certain length of wire is twisted into a coil shape. Certain length of wire is twisted into a coil shape. Certain length of wire, this wire is twisted into this shape, then it becomes as an inductor. Okay, so this is the inductor. Certain length of wire is twisted into a coil shape, that is nothing but an inductor. Now, this inductor also has certain property. Before going to discuss about that, how it will works. Okay, how it will works. For example, if we pass the steady current, what is the steady current? Steady current means constant current. Steady current means constant current or stable current. What is the other type of current? We have another type of current. That current is called alternating current or change in current. What are those types of current? Let us see this. Steady current or constant current means with respect to time, the magnitude of current I is always constant. The magnitude of current I is always constant. That is called steady current. What is the other type of current? Alternating current. What is this? Alternating current means the magnitude of the current will alters with respect to time. The magnitude of the current will alters. So, for example, at this instant, the magnitude is this much. At this instant, the magnitude is this much. At this instant, the magnitude is this much. Now here, the magnitude is 0. At this instant, the magnitude is this much. At this instant, the magnitude is this much. And at this instant, the magnitude is like this. At this instant, magnitude will goes to 0. Here, what we are observed here, the observation is the magnitude of the current will alters at every instant of time. The magnitude of the current will alters at every instant of time. That's why this current is called alternating current. Remember these two. Now, if, for example, if we are going to pass this type of current, what is this type of current? Steady current or constant current. If we pass this steady current, see here, the difference between steady current and alternating current is, steady current is always represented with capital letters. Alternating currents are always, alternating letter or quantities are always represented with small letters. Here, these two are also I, but this is a small I, this is a capital I. Capital I represents the steady current or DC. Steady current is also called a DC current. Steady current is also called a DC current. DC current means direct current. Direct current is nothing but constant magnitude of current. Okay. Other one is alternating current. It is represented with the small I. So that is the difference between DC current and AC current. Now, if we are going to pass a steady current or DC current through the inductor, whenever we pass a DC current to the inductor with the help of the DC supply, if you are going to pass a DC current through the inductor, then a magnetic field will set up around the inductor. A magnetic field will set up around the inductor. A magnetic field, whenever a steady current or DC current passing through the inductor, a magnetic field will set up around the inductor. This is the property of the inductor. Not the property, actually, when a DC current passes, some certain amount of magnetic field will develop around the inductor. For example, if current magnitude increases, the magnitude of the magnetic field is also increases. The magnitude of the magnetic field will also increases. For example, if the magnitude of the steady current decreases, this magnitude will also decreases. The magnitude will also decreases. Small amount of magnetic field will develop around the inductor. If current decreases, magnetic field decreases. If current increases, magnetic field increases. This is the duty of the inductor when DC current passes. For example, through the same inductor, if you are going to pass AC current, if you are going to pass the AC current through the same inductor, AC current means alternating current. The alternating current passes with the help of the alternating voltage. So the alternating voltage supply represented with the sinusoidal signal. The alternating voltage is also represented with the small v. Now the current passing through the inductor is small I. This is the inductor. Okay. Now, if this type of alternating current, this type of means if an alternating current is passing through the inductor, what will happen? When a current passing through the inductor changes, a magnetic field will set up around the inductor. At the same time, an EMF will be induced in the inductor. Okay, if an alternating current is passing through the inductor, alternating magnetic field will changes around the inductor. At the same time, the voltage is induced around the inductor or across the inductor. An EMF will be induced across the inductor. Okay, so that induced EMF is also represented with V suffix capital L. Okay, whenever an alternating current is passing through the inductor, alternating field will set up around the inductor, that will result in EMF will be induced across the inductor. That induced EMF is VL. What is that amount of induced EMF? That amount of induced EMF VL is equals to L into rate of change of current. L into rate of change of current. Okay, voltage induced across the inductor is VL is equals to L into di by dt. What is this L? This L is the inductance of that particular coil. What about this di by dt? Rate of change of current passing through the inductor. Okay, if di by dt increases, VL increases. If di by dt decreases, VL decreases. Why? Because inductor L is constant. Why it is constant? Inductor is made up of with a certain length of wire twisted into a coil shape. The wire is made up of either a aluminum or a copper, like that. So the material is constant. Okay, the length of the inductor is also constant. So that's why L is constant. If L is constant, VL induced EMF across the inductor is proportional to di by dt. So that's why here, if di by dt increases, rate of change of current passing through the inductor increases, voltage across the inductor will also, voltage induced across the inductor also increases. If the rate of change of current decreases, the induced voltage across the inductor will also decreases. This is the VL voltage across inductor, that is L di by dt. Now, how much amount of current is passing through the inductor? In order to get the current passing through the inductor, we have to differentiate this on both sides. We have to integrate this on both sides. Then, if you are integrating this, integral VL dt is equals to integral of, is proportional to integral of di by dt. If proportionality is eliminated, L into integral di by dt. Okay. Now here integration, differentiation cancel. Then L into I is equal to here integral VL dt. Then I is equals to 1 by L into integral VL dt. So how much amount of current is passing through the inductor? I is equals to 1 by L into integral V dt. Voltage across the inductor is VL is equals to L into di by dt. How much amount of current is passing through the inductor? The current passing through the inductor is I is equals to 1 by L into integral V dt. Okay, this is about the inductor. And another property of inductor is another two properties of the inductor is, whenever a change in current is passing through the inductor, it will opposes that change in current. It doesn't allow that current immediately. It will opposes that change in current. If a same current is passing, there is no problem, there is no issue. It allows that current. Suddenly, initially, for example, if 10 amperes of current, rate of change of current is 10 ampere, if the same 10 ampere is passing, there is no issue. Suddenly, from 10 amperes to 15 amperes, the current will change from 10 ampere to 15 amperes suddenly. Then inductor will opposes that change in current of 5 ampere. Okay, immediately it doesn't allow that change in current, but it allows that current slowly. That is another property of the inductor. The third property of the inductor is, it will store that energy supplied by the supply. Energy supplied by the supply is stored in this magnetic field. Okay, the amount of energy supplied by the supply or a source is stored in the magnetic field. That energy stored in the magnetic field is EL is equals to half L I square, half L I square, half L I square. That is the energy stored in the inductor. So here we have discussed about the voltage across the inductor, VL equal to LdI by dt, and current passing through the inductor, I equal to 1 by L integral V dt, and here energy stored in the inductor, EL equals to half Li square. This is about the inductor. Now we are going to discuss about the third component, third element or a component, that is called capacitor. The third one is called capacitor. Capacitor is also a device or a component. Okay, capacitor is also a device or component. It has some capacitance. It has some capacitance. The difference between capacitor and capacitance is represented with C, capital C. What is the difference between capacitor and capacitance? Capacitor is a device or a component. Capacitance is the property of that device and component or component. Capacitance is the property of that device or component. How the capacitance is formed? Let us take two conducting electrodes. Let us take the two conducting electrodes. The two conducting electrodes are separated by, place the two conductors side by side with some distance, and these two are separated by some medium. These two are separated by certain distance with some medium. Two conducting electrodes A and B are separated by a small distance d with some medium. This medium is called dielectric medium. This medium is called dielectric medium. This medium is called dielectric medium. Two conducting electrodes A and B are separated by a small distance d meters with some dielectric medium. Then it forms as a capacitor. It forms as a capacitor. That is a device or a component. Now what is the capacitance? And the capacitance means the property of this device. The property of the device is called the capacitance. What is that property? We will discuss now. Now, for example, if it is connected to the supply, if it is connected to the supply, if it is connected to the supply of V volts, if it is connected to the supply of V volts, then if it is connected to the supply of V volts, then the current is passing through the capacitor. The current is passing through the capacitor. Now let us take this as a voltage, DC voltage. Now the current is also a DC current. Now, what is the current passing through the, what is the current passing through the capacitor? The current passing through the capacitor is C dV by dt. C dV by dt. How it is getting? Before that, actually capacitance, actually I is equals to dq by dt. I is equals to dq by dt. Okay, dq by dt, rate of change of charge flowing. Current is nothing but rate of flow of charge flowing. So I is equals to dq by dt. What about q? Q is equals to C into V. Q is equal to C into V. So that's why if Q is replaced with C into V, then we will get this equation. I is equal to C dV by dt. Okay. Okay, now here these conducting two electrodes are made up of with some material, constant material. So that's why electrodes material is also constant. And before that, what is the capacitance C? C is equals to epsilon into A by D. Epsilon into A by D. What is this epsilon? Epsilon is belongs to this material which is used to made up of with these electrodes. So that's why the material is constant, epsilon is constant. Epsilon is some other epsilon equal to epsilon naught into epsilon r. Okay, that is the other matter. Now here epsilon, that particular material is constant, that's why epsilon is constant. Then C proportional to A by D. Then C proportional to A by D. What is A? What is D? D, I was already told you that D is distance between the two conducting electrodes. What is A? A means cross-sectional area of the conducting electrodes. Cross-sectional area of the conducting electrodes. Okay, if these two plates are with the same area, same material with same thickness, the area is also constant. Okay, so if these thicknesses are constant, area is constant. Otherwise, area will differ. Okay, now here C proportional to cross-sectional area, C inversely proportional to distance between the plates. Okay, now if the distance between the plates increases, corresponding capacitance will decreases. Okay, if distance between the plates increases, corresponding capacitance of the capacitor will decreases. If distance between the plates will decreases, the corresponding capacitance of the capacitor will increases. If distance between the plates decreases, corresponding capacitance will increases. Coming to the cross-sectional area, if the cross-sectional area of the plates increases, the capacitance of the capacitor also increases. If cross-sectional area of the plates decreases, capacitance of the capacitor will also decreases. Now finally, after constructing or after made up of the capacitor with a certain material, capacitor is already constructed, designed. So that's why the material is constant, epsilon is constant, plates area is constant, plates are constant, so area is also constant, and the distance between those two plates are also fixed. So that's why D is also fixed. If D is also fixed, capacitance is also fixed, that means constant. If capacitance is constant, then I proportional to dV by dt. I proportional to dV by dt. This is the current passing through the capacitor plates through this closed circuit. Through the capacitor plates, the current passing through this entire closed circuit is, this is the I proportional to dV by dt. How much amount of voltage will be, so when the current is passing slowly, then automatically after a certain time, the voltage will exist across these two plates. The voltage will exist across these two plates. What is that voltage? How to get that voltage? Integrate this expression on both sides. Now, take this dt into left side. Now, I into dt is equals to dV. Now, integrate the equation. Integral I dt is equals to integral dV. Now, here integration and differentiation both are cancelled. Then V is equals to or VC, voltage across capacitor. Voltage across capacitor is VC. So then VC is equals to integral I dt. Okay, integral I dt. Sorry, here this is the proportionality. Voltage across the capacitor is proportional to integral I dt. If, for example, if we take this complete expression C dV by dt, then here eliminate the proportionality with equal to symbol, then we have a C. So therefore voltage across the capacitor is, we have a C, that is 1 by C integral I dt. Okay, either this I is either a small capital I or a small I also can applicable. Okay, here capital I or small I. Capital I means DC current, small I means AC current. Okay, so this is the voltage across the capacitor. Remember all these equations: voltage across the capacitor, current passing through the capacitor. Okay, finally here I will note down the voltages, currents, relationships in resistor, inductor and capacitor. Resistor R, inductor L, inductor L and capacitor C. And capacitor C. Okay. Now, voltage across the resistor is VR equals to V equals to I into R. Voltage across the resistor is equals to I into R. Current passing through the resistor I equal to V by R. VR means voltage across the resistor. That's all. That's enough. Okay. Don't confuse here. This is belongs to resistor. R means resistor. This is voltage. Voltage across the resistor. Here I is equals to current passing through the resistor equal to voltage across the resistor by resistance value. Now coming to the inductor. Voltage across the inductor VL equals to L into di by dt. L into di by dt. Current passing through the inductor I equals to 1 by L integral VL dt. Simply here VL means, L means inductor, V means voltage. Voltage across inductor, that's all. Don't confuse it. Okay. Then coming to the capacitor. Voltage across the capacitor 1 by C integral I dt. These are already discussed right now. Either small I or capital I. Now current passing through the capacitor is C into dV by dt. These are the formulas which are related to resistor, passive elements, resistor, inductor and capacitor. Okay. And one more, these are already getting from Ohm's law. These are already getting from Ohm's law. Okay. So today's topic is, what is the today's topic? What is the today's topic? What is the today's topic? Today's topic is passive elements. What are the passive elements? Resistor, inductor, capacitor. Where we have started? Electric circuit. From electric circuits to Ohm's law. Ohm's law to different elements. Resistor. First element is resistor. First element is resistor. Okay. Then inductor. Then we go for third element, capacitor. Finally, the consolidated voltage and current expressions for resistor, inductor and capacitor. These are the expressions. Remember all these equations related to the resistor, inductor and capacitor. In the next class, we will discuss about series connection of resistors, parallel connection of resistors, series connection of inductors, parallel connection of inductors, series connection of capacitors, parallel connection of capacitors, and their combinations, series and parallel combinations. So that's why remember all these equations. Okay. Then we will meet in the next class. Thank you all.